Good morning, Algebra 1. This is the last lesson in Unit 2, linear inequalities and two variables. The first exercise is just which one doesn't belong. Between these four graphs, I think I can make an argument that each of them don't belong in their own way. If I look at A is the only graph that is not a graph of an inequality. These are just equations. There's no shaded region. So A doesn't belong because it's the only graph of equations. Part D is the only graph that has one inequality or equation. Part B is the only one that has no solution. The solution to part A is where the lines intersect. The solutions for D is all these points above this slanted line. In part B, there is no intersection. All the solutions to the top line, the blue region, none of those solutions are going to work for the bottom region because they never intersect. There's no overlapping. So this one has no solution. And part C is the only one with a system with solutions. It's a system of inequalities, and it has a solution set. Right, the blue region is all the solutions to the top line inequality, and the dashed line is all the solutions to the vertical line. So there is some overlap in this box right here. Any point in here, for example, 6, 6, would be a solution to both inequalities. So now focusing on the details, 25.2. Here are the graphs of some inequalities to the system x is less than y and y is greater than or equal to negative 2x minus 6. Our job is to decide whether each point is a solution to the system and explain how we know. Now we can figure out if any of these points are a solution by looking at either just the inequality or just the graph. And I think looking at the graphs can be a lot easier. The inequality x is less than y is this dashed line here on the side. And all the points in this blue region are all the times where x is less than y. And if I looked at the line y, the inequality y equals negative 2x minus 6, that's the one that has a negative slope. The dashed lines are all the solutions to that one. So the overlap region to both these inequalities is this kind of triangular region right here. So anything in here is going to work for both inequalities. So when they ask us if any of these points are solutions, if it's in this yellow region, the answer is yes. So let's see. 3, negative 5. 3, negative 5. Well, it's going by 2, so 3 is right between 2 and 4. And I got to go down to negative 5, negative 2, negative 4, negative 5. So that's not a solution because it's not in the yellow area. It's not in the solution set. So although it does work for the second one, it doesn't actually work for the first inequality. And we could look at it without looking at the solution set. Is x less than y? Is 3 less than negative 5? That's a no. So that's why it doesn't actually fit the bill. All right, now next one is 0, 5 in that solution set. 0, 5, 0, 5 is going to be right here. And yes, it's in this loop. Yes, 0, 5 is in the solution set. Is 0 less than 5? Does it work for the inequalities? Let's see. 0 is less than 5. And if I plug into the second one, would that also work? If y is 5 greater than or equal to? Well, if x is 0, negative 2 times 0 is 0. 0 minus 6 is negative 6. Is 5 greater than or equal to negative 6? It sure is. So it works for both inequalities, and you can also see it with the graph. So there's two different ways of justifying that. Negative 6, 6, negative 6, 6, 1, 2. So that's right here. Is that in the solution? Well, let's see. It's on this solid line, so it's definitely a solution to this dashed line. Actually, not this dashed line. This region that's shaded in with these lines, and it's obviously in the blue region. It does fit into this yellow triangle area. The answer is yes. It is in the solution set. If this line was a dashed line, it wouldn't be, but because it's a solid line, any point on that line is going to be in that solution. And it's going to work for both of these inequalities. Is x less than y? Is -6 less than 6? It sure is. And is y greater than or equal to -2 times x minus 6? Well, -2 times -6 is positive 12, and 12 minus 6 is 6. Is 6 greater than or equal to 6? Well, it's equal, so that is greater than or equal to. 3, 3, right, over 3, up 3. So this one's tricky, and this is actually a no. It's going to fail, even though it's on the dotted line. The dotted line doesn't actually include the points on the dotted line, and it's going to fail this first inequality. Is x less than y? Is 3 less than 3? It's not. So it doesn't satisfy x is less than y, and it's not in the solution set. Right? This is the solution set. Okay. And last but not least, is -2, -2 in there? -2, that's right here. Again, that's going to fail just like this number 4 did. It's on the dashed line, and if you're on the dashed line, you're not actually a solution. It's going to fail the first one again. Is x less than y? Is -2 less than -2? And it's certainly not the case. -2 is equal to -2, not less than -2. So also this one doesn't satisfy the first inequality. And it's also not in the solution set. Anyways, that's it for this part of the lesson 25.2, focusing on the details. If you have your solution set graph, then all you have to do is look at points inside that graph and see if they work. If they're inside your solution set, you got a solution to both inequalities. If it's not in the solution set, then it's not going to be a solution to the inequalities. And just be careful with the dotted lines and the solid lines.